Arrow functions provide a highly streamlined modern syntax for writing functions in JavaScript. However, it's not just about clean code, they introduce fundamental differences in how your code executes. Let's talk first about the syntax. In a traditional function, we have the function keyword, we have a name, our parameters, and then the code block that's executed when the function is called. We're going to use a couple of different approaches here so that we can transition toward the most concise way to do arrow function syntax. First, we will rewrite this traditional function while preserving the code block inside the curly brackets. The first thing we want to change is to store the function in a constant. So I'll declare a constant. We're going to call this one block arrow calculate fuel for an alternate version. And then we store the definition of the function inside this constant. We're going to start with the parameter mass, and then use what's called a fat arrow, which is a combination of an equal sign and a greater than sign, and that takes the place of the function keyword. So all that remains is the body of code that's to be executed. With this transitional format, we'll open up the curly braces and then use the return keyword and return mass times 11.2. So this part of the function, the code block, looks identical to the traditional syntax. But the main difference is that we're storing it in a constant so that this constant name becomes an alias for this entire function, which is really an anonymous function, which we'll talk more about in the next demo. So now that you see that slight change of replacing the function keyword with this fat arrow and storing the entire thing in a constant, let's look at an even more concise way to write this function. We'll create another constant. I'm going to call this concise calculate fuel. And we don't need the parentheses whenever we have a single parameter. So I'm just going to say mass, use the arrow, and then instead of having curly braces in the return keyword, I will just have what's called an implicit return with mass times 11.2. So what's happening here is that this very short line of code that was inside of our block can be returned in one line without the braces and the return keyword. And that's actually important. If you use an implicit return, you have to either use the curly braces and the return keyword or use neither of them. So in this case, we've left them both off so that we can just return this. And this is a really nice, clean way to write a function when it's very small. If you have a function that requires multiple lines of code, you'll need to do it this way where you still have the block and the return keyword. Let's test our new function. I'll just log a quick statement here. We'll say implicit return fuel calculation. And then we'll call concise calculate fuel, pass in 100 as the mass, and then label it in metric tons. Let's run it. And we see implicit return fuel calculation, 1,120 tons. Now that you understand the difference between the traditional syntax and the arrow syntax, let's talk a little bit about how using constants changes the way your code executes. We have here a traditional function, read traditional sensor. Let's try calling it on the line above it. And again, I'll use this approach of logging something. And I'll say traditional probe reading, and then inside the placeholder, we'll call read traditional sensor and run it. We see traditional probe reading telemetry active. Okay, so we have shown that we can call a function before it has been defined, but that's only because we used the function keyword, this traditional syntax. It doesn't work the same way with constants. I have a constant read arrow sensor here that is an alternate version of the same function, but it's stored in a constant. Let's try calling it from here. We'll say arrow probe reading. And this time I will call read arrow sensor. And we'll try running it. And we get a reference error. It says cannot access read arrow sensor before initialization. So this just shows you that if you store a function definition in a constant so that you can use that constant as an alias, you have to define it before you use it. Let's copy this line down and call it below. And I'm going to comment this line out so that it doesn't crash our program before we get to line 40 here. Okay, and this time we see arrow probe reading, telemetry active. So those are the basics of arrow syntax and storing function definitions in a constant. In the following demos, we're going to learn more about anonymous functions and the different ways that they're used in practical use cases. Let me make a quick commit. And let's take a look at your practice. You have some different functions here that you can start with the traditional function and transform it into an arrow function that works the same way. And then down here, you're going to have some code already written for you, and you're going to have to figure out how to fix it so that it works correctly without crashing the program. That's all I've got. I will see you in the next one.